Hi, this is a quick demo of the package that I have called langchain-advertools, which is an integration for the advertools package into the langchain ecosystem of supporting packages. And the main class that is provided right now is called website loader, which is a document loader. So I'm gonna show you how this works, and then once we have that ready, we'll use another community package to do embeddings and similarity between pages. So let's see how things work. So first, I created this cosine similarity function. Thank you, OpenAI, and we're going to use it later. So the workflow here is the following. We define a website. So I'm gonna crawl the langchain.com website, and I define an output file variable. Let's call it langchain.jsonl. And this is the function that's mainly used for crawling this website. And all you have to do is set the URL list and output file. Follow links equals true means do it recursively until you finish all pages on the domain. Okay. Now, once this is done, this is a small website, like 39 or 40 pages. You can read this into a pandas data frame, and the website looks something like this. So this website has been converted to a data frame, and as you can see, we have the title, meta description, viewport H1 through H6, canonical tags, structured data. This is going to be very interesting. The body text, I'll show you in a moment. The size, so much data, links, images, request headers, response headers that give you a very, very rich representation and context about the crawled website. Now, the website loader class makes this compatible with the langchain document object. Okay, so you instantiate this simply by creating the class with the output file, and we read it, we load it lazily with the lazy load method as usual. So let's take a look at one of the pages. We define the home page. So we have three main attributes: the ID, the page content, and metadata. So the ID is the URL, because this is a unique way to identify the page, and this is killer feature number one. Let me show you why this is a killer feature. So this is the page content. This is not the HTML. This is the parsed content. There's no extra work that you need to do. This is done by default. And let's take a look at the actual page. So this is quite complicated structure, and if you want to parse this with your own selectors, it's going to take you a lot of time. And once you're done with that, you're going to have to do the same thing for other pages. So there's a header here, but the actual content that we're interested in starts with the platform for reliable agents. And as you can see here, the platform for reliable agents, tools for every step of the agent development cycle. As you can see, it's parsed here for us. So gain visibility, and improve quality. See what's happening, so you can quickly trace. Everything is parsed until the last thing that we have here, every step of the agent development lifecycle, get a demo, sign up free, which is here. It ends here, and it doesn't parse the footer. Okay, and it does this by default. Of course, you can customize this if you're interested, and obviously it's not perfect, doesn't work 100% of the time, but I think it's quite a time saver and makes it easy for you. Okay, killer feature number two is the very rich metadata dictionary that you get for every page. So these are basically all the attributes here, all the dimensions in this data frame given to you here. So in your LLM applications, this gives you a very rich context about the page that you've crawled. So for example, you can look at the title tag, the meta description, H1, H2, the size of the page, links, anything over here, you can have it, and you can feed it to your context as part of the context in any application that you are building. So that's pretty much it. I'd like to show you one use case, which is how we can use this for getting embeddings and using cosine similarity to see how pages are similar to one another. Okay, so we're using the OpenAI embeddings class, and this is the model, and you put your OpenAI API key here, and you run this. So this is the same loader that we did a few moments ago. I just wrote it again here for clarity, and we loop through the pages, and we use the embed query method here, and we append the results to this embeddings list. So this embeddings list looks like this. You have URL, and then you have a list of the embeddings. These are just the first 10, just to give you an idea of what's going on here. Now that we have this, we loop through all the combinations, the product of embedding list with itself. We compute the cosine similarity, and the similarities list looks like this. It's a bunch of tuples. This page with this page have a similarity of this. Obviously, it's pretty much 1. This page and this page have a similarity of 38%, and so on. Okay, and now we can easily create a data frame, URL1 and URL2, and their similarity. And one thing you can do is you can sort by similarity, skipping the first 41 pages because these are compared to themselves, so you have a perfect one. But these are the pairs of URLs that are most similar to one another, ranging from 90% to 80%. So that could be interesting. Another thing you can do is select a specific page. So I'm going to take the home page, and with this code over here, I see all the other pages and how similar they are to this page that I selected, and they are sorted by similarity here, as you can see. So you can see if these are linked to one another properly, if they are connected conceptually to the users, and so on. All you have to do is replace the URL of choice over here. If you want to make this a bit more intuitive, you can just pivot this data frame. It's more intuitive, but a bit less usable. But it's great to explain this to other people. If you want to go a bit more fancy, you can do a heat map of the cosine similarities across the pages of this website. Now this might work because it's a tiny page, about 39 URLs, but if you have 1,000, then you're going to be looking at 1,000,000 pixels here. So I think this format is ideal for this, but this is great for demonstrating, and you can glance here, for example. So privacy policy is not similar to anything else, which is great because this is legal language and has nothing to do with LLMs. Terms of service as well is dissimilar to pretty much everything else, and you can see this clearly over here. Yeah, that was a quick demo of this package. I hope you take a look, you use it, and I hope you like it, and you let me know what you think. Thank you very much.